Hello, everyone, and welcome to the broadcast. I am newtmechanist, and today we're finally continuing our game dev project. Had a bit of a down week there, but we should be back up and operational, at least for a bit. Let's check in with the kitties real quick. We do have Ember across from the keyboard, Sherbet over on the shelf, eyeballing me when I mentioned him. We have Sammy over in the play area. I moved the canvas on the table there and she was displeased. And Sky snoozing on the bed. We do not have eyes on Mason at the moment. And Molly is down at my feet. But yeah, back to the project today. Have been working on a couple of things since we last saw. I wanted to keep some momentum. So let's take a quick look here. Okay. So I've created a bunch of what I'm calling colliders here. The pattern is similar to what we did for visual content. So let's see here. Let's get the little bits. Collider. So what we've got, one, we've created the concept of an entity area 2D. See, we are joined over here. I see somebody has joined in tall format there. As well as Nope over in widescreen. Well, thanks, Endo. I'm glad. I'm happy with how it turned out as well. But hello, both of you. We are just getting started. So we created this. This is just an area 2D that has an entity associated with it. We kind of need that. We have indicators that it should go away, that it bumped into something else. We have offsets, so this is where we should position the actual collision area separate of where the entity moves. This is less necessary now, or at least in the direction we're going to be going today. But it's there in case we need it. We have collision scale. This is something that was working, but I was technically doing wrong for a bit. I was using the node level scaling values. Apparently, collision doesn't always play nice with that. So we're going to dodge the problem by using this as a multiplier, and this bubbles down at the service level. So when we create it, we hand it the scaling factor. Suction Cup Man. I know there was a period of time where you would get like the human fly and whatnot, and they would use big ol' like suction cups in order to scale skyscrapers, usually without the consent of the building owner, resulting in problems. But what are you referring to, Nope? One of the nice things about setting this up this way is this is another thing that we could use going into things like unit tests, since we can just supply parameters to some of these in order to trigger some of the initial logic. Huh. But we pass this in so that we can use it elsewhere, so that I don't have to hard code it. And I don't have to have the services reach up into the global space them as well and fetch this value. Keeps things from getting tangled. But anyhow, so we're going to hop back into our collider here. So we've got that. We have a node, we have an entity, but we're going to go in and we're just going to work at this level for just a moment. Our catalogable copy constructor here. The only things that we actually need to copy currently are the offsets. How the offset gets affected, how we deal with the positioning, those are all specific to individual implementations. The only thing that is consistent is that it expects a node. So right here, we go in, we create it, and we say, here's a node, here's an entity, here's how big you should be. Here's how big you should multiply your layout. Default for setting the entity. We use extensions of this later. And we have an invoke here because it's the child classes can't directly invoke these. There might be a way to do that, but so far no. Or at least I haven't looked hard. This pattern works. Then if we jump into the next level down, this is an implementation that uses the entity area type. It's going to use an area 2D. In theory, I could have this live lower down. Because nothing else knows about area 2D. I'm going to leave it here for now. We use it extensively further down. But big thing here is just that's not right. Oh, okay, no. Misread that. Never mind. This is a copy where we don't have any copy operations to do yet. I just have the shell in place. Similarly, we don't have special initialization we do, so we're just going to let the parent class one fire. Similar with set entity, we're going to call the base one. What the base one of this does is it stores the entity variable. Great, we've got that. If we have an entity when we get here, we're going to do entity stuff with it. We're going to create that area. We're going to set the scale of that area. This is where that scaling value comes in. For the most part, it's just a multiplier. We grow it or shrink it. So we're getting our entity stuff like what it collides with, what type it is. It's the player. It collides with nothing. It's a bullet. It collides with enemies. That kind of thing. Look up our events. Right here, it's making it possible for the collision to happen, which should be here, actually. So here we're listening to the entity. So if the entity goes away or if the entity's position updates, the order doesn't matter. for this because it's all happening within a single functional loop, but I just want to be sure. Physics technically runs in its own thread. So it is possible that I mess something up down the road. So we want the function that would handle collision hooked up before collision gets turned on. We turn it on, we set where our position is, and we apply the offset to the position. So, and then we're attaching to the node. Again, we're going to get to where these nodes are coming from. That's a whole song and dance that I went through. Beverage. All right, we're going to look at the simplest implementation of this first. And that's a circle. Circles just have a radius. So we're extending upon the idea of an area 2D here. We have a space for a shape to be in. This is going to add that shape. So when we initialize this one, we go in and we say, okay, I'm going to make a shape that is just, this is defining that the area will contain a shape of some kind, a circle, a square, that kind of stuff. For collision purposes. Then we are going to get the actual shape, this, a circle. We set its radius and we attach it to that collision shape here. What this results in is, from the outside, it just thinks, okay, this is a collider. That gets defined in the entity, and we use it when we add it to the collision logic. Let's get these visuals out of there so we can keep this clean. I had the renderers open because the pattern is very, very similar. So here's our space manager for this. Part of the driving force behind this is the node cache, and then we have a hash set for the colliders. So the colliders are unique entities. We don't care about a sequence of them, and we're not iterating over them. We just care which one is where. But otherwise, very similar logic as far as handling the collisions. Until the physics step comes around, we're just pooling those events. So end of the physics step, collision logic happens, the shapes entered happen. We pool these until the top of the next collision handling step. Great, okay. So we get a new entity. We're going to create a collider from it, given the entity's collider key. Might have a failsafe for a blank key. Currently, entities have collider keys. We wire up its events when it bumps into something, when it's supposed to go away. Pass in that initialize. So we've got the entity that was added. We have the collision scale of the whole service. And then we're passing in node cache get node. So this is some efficiency song and dance. So Godot doesn't like adding and removing nodes that are handled in the tree. The more of them you add or remove, the bigger the cost is. Hey there, Alistair. Welcome, welcome. We don't want too many of them to stick around because they have a cost to existing, but we don't want to have to add them frequently. We also don't want to have to remove them frequently. So what I set up was a node cache. And where did I put this? It should be in Godot helpers. There we go. Node cache. So this is... It stores nodes, and you have to be able to new them with no parameters. This is an expanding cache with some extra on it. So we have a stack of them that we're using. Reuse them in the newest order. Welcome over on the Twitch side, Alistair. Doesn't really need to be a stack. It could be a queue, but can be useful to reuse the newest one or the last one to get used, just to keep the reuse in there. But anyhow, this is the parent node. You attach a node cache to some node. In this case, the collision manager has a node that is where the collisions take place, where in the kind of collision land. But you pin them. When we're setting up a cache, we have the owner and we have the minimum size of the cache. So let's look over at our collision manager. Those wondering what we're doing, this is a recap of all the stuff that happened since the last programming stream. So we set up the cache to say, how big should entity-related caches be? So let's hop over to that. This is relatively arbitrary. You want it big enough. You want it big enough that normal use falls within the cache easily. But we don't want it so big. We want to give some elbow room for when we are running normally, and some additional space to handle kind of heavier circumstances. But we want the system to be able to run under extreme circumstances. 1,000 so far is pretty good. It could probably be lower than this, but anyhow. So we set the minimum size. What that minimum size is going to do is during the preload, we create nodes for every one of those. Each time we create a node, we make a new one. Again, these are, in this case, it's node 2D. We create a new one, we pin it to the owner, we put it back. Or we give that node to the cache or free logic. All the way down to here. So during this, we turn the node off. Do not. Can I do node.physics? Just. Okay. So we're saying don't do anything with this node. This node is asleep, more or less. And we say, okay, if I have a new node and we don't have a full buffer yet, I'm going to put it on the node cache. If we have a node is back and we are bigger than the buffer, then we are going to get rid of that node. We queue it to free. And we are resetting our buffer add to default. We'll get to that in a moment. When we go to get a node, if there's a node in the cache, we get the node from the cache. If there isn't a node available in the cache, we are going to create a number of nodes equal to how many we're adding currently. So that starts right now at 10. We start at 10, and whenever we increase it, we go up by 10. So right here, if I have to add them, I'm going to add 10. And then once I've added those 10, I say, next time we're going to add 20. So it kind of exponentially ramps up. I'm going to add 10, and then I'm going to add 20, and then I'm going to add 30. Those are adjustable. So we're going to put those in the cache. We're going to get them ready. And then we are going to create one more. Technically, it's like I make 10 plus 1. That's fine. Doesn't ultimately matter with the plus 1. I just noticed that. I make another one. But we make a brand new one, and we give that back. So if I am out of things to use, I'm going to keep doing this. I'm going to keep putting them in there. As soon as one goes away, we're saying, okay, if I'm over my queue, don't put it back. If I'm over my cache size, don't put it back in the cache. Let it decay away. I could have some value over that, where the minimum bonus needs to decay away slowly. Hello, Wyatt. The cat on camera currently is Ember. She is my tiniest cat. The camera is very close in, but she is very small. Good opportunity. Let's check and see who we can see right now. We only have 2 of the 6 visible at the moment. Yeah, I think that's a tag. So, Sky is on the bed, and Ember is across from the keyboard. Okay, we have one of the 2 brothers top center of the play area. Welcome over on the Twitch side, Wyatt. If I had to guess, that's Sherbet. I don't have good line of sight. But you can see his tail there. Molly is still on my footrest. Okay, so anyway, we have a cache that will grow as we need it, and then when we start removing them, if I don't need another one, if I'm still over my buffer limit, then I get rid of it. This lets the cache fall off down to whatever its minimum is. Again, it might be good to have a sort of decaying multiplier on this. That as I free them, it gets more aggressive about letting the cache go. If it has been adding more and more of them. Like, instead of the buffer add minimum, I could reduce it by the buffer increase there. And just steadily let it fall away, kind of thing. Anywho, so this gives us our cache. The visual processing and the collision processing uses this. Encapsulation, code reuse, good things, good things. Things that I coded in the fits of madness that that make up my sleep deprivation. So we set up our node cache. Whenever we add something, we get the collider, we put it in. We are checking to see, we have the ability to check and see, is this collision already present? For this round, has this entity already collided with that other entity? We only do a collision once. Like right here. Like if we get a collision detected, we're going to check and see if we've already done that one. Or we're about to do that one. Here is where we process all of those collisions, and then we clear out the collection. Okay. And we're doing similar with that. Let's see if the code is still in a functional form. I think it should be. I did mess with the data files a little bit earlier, so I may have broken something. But I don't think so. Okay. Let's look at it over here. This is a testing scene that I'm using to verify a visual aspect that we're going to be drifting towards. So I want to be able to do two things. I want to be able to do slight sidetrack. We will get to what I was saying where I was going to demonstrate in just a moment. I want to move away from the actual sprite being the thing that we're wrapping hit detection around, and instead say, I'm going to draw kind of an ellipse around their feet. I could do a circle, but probably going to be an ellipse, just that's kind of standard. It also matches the usually not quite 3/4 view. You know, it's not full side on kind of thing. Not full isometric. But kind of. Anyhow, so we're going to put the sprite, assuming it is a creature sprite, with its feet on the ground. So like the yarn ball would be touching the ground with its side. The blobs touching the ground when they bounce. At the point where they are, so the center of the bottom of the part of the sprite that is visible, so like the feet of the player, touch the ground at the point that it exists at. The drop shadow, a little kind of black ellipse, is drawn under their feet to show you this is the area that that creature occupies, that thing actually exists in the world. That will make the collision logic much easier. Again, if I need to use a circle, I'll use a circle. Circles are, collision-wise, the cheapest ones. But capsule is more accurate to the shape that we'll be dealing with. This guy is being a bit of a troublemaker today. Isn't that right? Yeah. Giving him some nose scratches. Because of that, an additional bonus of that is that the circle is where they are, visually where they are. So if you're following the shadows, you can see where, you know, the character or similar, where they are. By decoupling the shadow that represents the location from the actual entity sprite, it gives us the ability to say, this entity is up in the air by putting the sprite higher up, but the shadow's still where it is. There are a couple of things that I want to use that for. Part of the vision of the yarn ball is that it kind of arcs and bounces. You know, comes down, impacts, and then might like bounce or roll along the floor kind of thing. Maybe it bounces again on impact. So, hits something, leaps into the air, comes down, and rolls until it hits something again. Oh, Sammy saw something. What are you doing? She was looking right up the camera for a minute. But to the point. If this sprite is in the air, so you can see the red is higher up. So both these are, as far as the game world would be considered, side by side. The blue, the shadow spot, is lined up on the y-axis. The red, the sprite, of the one on the right is like on the ground. It's touching the center. Whereas the one on the left is, in the air. So if they are right over each other, it doesn't really matter which one of those two would be in front. But if and these are Y-sorted, so if it's down here, it's in front. You can see the little black square there covering the red. The one that is lower down is in front. And if it's up above, it is behind that one. It is behind that one despite the fact that the red here is lower down as far as the Y coordinate would normally be concerned. That's because the whole kind of assembly here is at its own Y coordinate. So again, the center of the blue is where this cluster of them is. That's what we need to preserve. And ideally that will work. But we'll have to make sure. We'll have to make sure that when we move around that we're doing things like moving the node. That'll require tuning, but that's what this testing was for. Let's do the actual run. We're going to make sure visible collision areas. Weird. Run the project. Okay. So you can see I've got a little square drawn around the player sprite. We currently have overlarge circles drawn around the blobs and circles very tight to the yarn balls drawn around them. The problem that I saw with this was that the collision zone for all of these ends up being very precise to what the sprite looks like. And especially with the blobs, that makes it really inaccurate. Like I could draw a little square that goes up around the whole height of the blob or similar, but I don't want to have the collision zone change as the blob bounces. So instead, just having a little like ellipse under the blob would mean that I'm just tracking where it's standing. Same with the player is the player right now is a gigantic hitbox. Comparatively. So how do we start with this? Well, we start by going in and making some colliders. Can I zoom this in at all? I could change the font, but that's usually not what we actually want to do. It's not the toolbar. I'm looking intently. Ah, there we go. All the way down to the bottom. Okay. Plenty big. So right now we have the player is a rectangle. And we're offsetting the Y here. Like we're moving that square around to make it the right size. So we're just going to set that offset to 0. This will make whatever the collision shape is centered around the point that the entity exists at. We're going to change this to a capsule. Capsule is kind of a pill shape. It's the closest to an ellipse we can get. In theory, by using a weird scale value for the node, you could squish this circle. But the collision logic that runs in the background supposedly doesn't fully account for that. Okay, so this is going to be radius, actually. All right, let's look at our sprite here. So this is kind of the relevant area here. So that's about 12 wide. So we want the overall circle to be 12, and we're going to say its radius should be 6. No, that's not quite right. Radius can't be 6 because that would be a circle of size, of radius 6. If we want it to be 12. So let's see here. For visibility purposes. If you can tell, this is not quite black. The outline is not quite black. This is a full black. But this is a really dark purple. That does is it lets us use things like black in the actual sprite while still creating a slight visual differentiation. So we would want a minimum of like that. But that's also really, really tiny. So if we were to do something like that, that gives us a radius of 2, and then I think the logic is then a height of 10. We'll see if that works. Save that. We haven't changed the actual sprite yet. We're rotating it 90 degrees so it's left-right instead of top-bottom. This should totally work. Wrist is acting up a bit. It's still pretty tiny. Let's try 14 here. Inside. Oh, I fixed it so it can be. If you notice, I had the file open. You can do them at the same time now. That was another thing I corrected before. It would be very unhappy with you if you had the file open at the same time. Let's also get our do I have the logic in the visual? I need to see if I've got the offset in here. And I do not. I'm just trying to make this very similar. So when these are applying the offset, we want them to apply the offset to the correct thing. We're also going to have to decide ultimately how the shadows come into play or not. I might bake that into a single visual. Does it have a shadow, and what kind? Kind of like the sound of that it be baked into the visual object. But, tricky. But for now, okay, so we create the sprite. Set up its animations. This is if we need to rotate it, if we need to flip its position. we are changing the position. Excellent. Okay. This is convenient. I'm moving the node. Okay. So we're not doing anything with this here. It's already protected. Go into collider. Yeah. Collider area. Okay. Just making sure that we've got the values in the right place. For the most part, colliders are a little different in that the node doesn't move around in the same way. I could have node's position move during this. Which would mean that we could move the set entity stuff outside and have collision logic tied in there, but we're not going to. Just stream of consciousness here. And again, folks, if you're not familiar with the project or coding or the code that I'm doing, don't worry, you're not expected to. That's fine either way. But for the most part, it's a relaxed, mutual learning experience. Hey, Dodds, welcome. Okay. We're just going to leave that alone for now. So we're going to apply the offset. Here. Which would mean we need the same offset X and Y here. We're using floats because almost everything in Godot uses a float value. Okay, now we have an actual copy operation to do. I could probably come up with a template for this. But it'd probably be more trouble than it's worth. This is a entity. Typing is going to be even more impaired than normal. Hey, sharpshooter. Right now, Sky is on my lap in the way. In addition, my wrist rest for my keyboard needed to be scrubbed down. It is definitely going on end of life. So it is currently draining and drying off. with me anticipating that I'm either going to need to go find or order a replacement in the immediate future. But that means I've had to pull my keyboard out of normal arrangement, so it's throwing me off even further. Is equal to this as an entity visual. Set x is equal to that. Set y is equal to that. Okay. Added those in. That is Sammy. And that is also Sammy's spot. Of all of the places, each of them generally has their preferred locale. Maybe a couple of them, but Sammy is on the Squishmallow, pretty much in that position on it, like right over the mouth of the little dragon. Okay. So we've got our offset. We're going to go into sprite. We should have... She is currently in... curled up little kitty ball. We could really use an update position. Where we set the position and apply the offset, because we should always be doing that. But there's some wrinkles to it. Well, let's just make it work for now. The reason I say we should have a set position is that when I attach the entity to it, when I do a set entity, I should be... Yeah. So this node position is equal to entity position. Right here. So this feels like a good opportunity to say, I am changing the position. For now... Yeah, let's put that in there. Get them from here. I'm also not using them fully here. But it's a pattern, so we'll put the pattern in place. So then in Visual Sprite, so we're not moving the sprite. Yeah, when we apply the offset when it's the sprite, we are applying the offset to the sprite. Yeah. Okay, so no.position. If. Just making sure here. What? No. Then apply offset should be vector 2.0. So this recenters the sprite. No, we can short circuit this. Not really short circuiting it, but yeah. So we're only applying the offset once. When I get to the point where I'm adding a height property to this, as far as, are they in the air or not, and how much, then one of the things on this would be in update position, I'm changing the height. And as part of applying the offset, we have to account for the height in the offset Y. Because of that, we would apply the offset after each one of these. So let's actually... what this allows us to do is extend go into visual, update position. There. Anytime we change the position, we should be... This is another spot that I could have subscription to the events and have progressive overrides. Let's keep moving. So we get down to here. Let's see, we have created the sprite. Let's apply the offset. So we update the position when we set the entity. Hey, Vartek. Welcome, welcome. And then on entity position updated, we are updating the rotation of it. So we can update position. This is GD script. I'm sorry, this is Godot 4.4. I'm coding it in C#. I do as little as possible on the Godot side. Let's look at one of our screens here. So this is the game screen. This is the loading screen. It has a loading bar that does nothing right now. Main menu, it's got buttons. I only do this because it is convenient to do it in Godot. Like, I'm just putting buttons on the screen. I don't need to programmatically add or remove them. If I encounter that scenario, then this scene would probably be blank with all of the stuff handled in the CS file for that screen. Almost everything happens in CS under the hood, and in the C# stuff under the hood. Yeah. Coding in C++ is the reason that when people ask, like, hey, I'm thinking of getting into programming and, and making a game to learn. What should I use? And every now and then they'll say, like, should I use Unreal Engine? And my answer to that for a newbie programmer / game dev is absolutely not. C++ is the deep end. Learning to swim there by diving in, probably not your best bet. There are a lot of engines, even outside of like the big well-known ones like Unreal and Unity. Why not Unreal? C++. That's it. Well, that in the toolkit. So Unreal is a great, big, powerful toolkit, and you deal with it generally in C++. So you're dealing in a lower level language with a very complex and robust engine. Dodds over on Twitch making a good point. Remember, kids, don't build a nuclear reactor to charge your phone. Just buy a charger. If you're just getting started, you can try to learn elsewhere. And on top of that, the engine that you choose should be relevant to what you're doing. Now, Unreal can do pretty much anything. It is incredibly powerful, but that means usually you've got to do it all yourself. Whereas things like Game Maker, RPG Maker, to a lesser extent, Unity, Godot, they have a lot of tools for you. Like, just being able to do this and rig up the events and say, hey, all this is here. Those are shortcuts. They're super convenient. I don't have to build them. I don't know what Unreal offers, but I know, again, it's a bigger, more robust toolkit, which means you'll probably need to learn to use more of it. Things like Unity and Godot have great tools for 2D platform games. Even stepping into 3D. Platform games in particular have a huge set of tools baked right in. as far as using physics and things like Godot, it can be a hassle to find tutorials that don't use the built-in kind of gravity, friction physics, that kind of stuff, platformer physics. Way back, I learned to code in C++, kind of the C++ era. I would not wish that on new programmers. Do you learn good skills? Yes, actually. And I think people learning should be introduced to the concepts of C++, memory management, that kind of thing, performance. All of those are skills, or at least things you should be aware of. But you don't need to do them yourself. Like, I want to just deal with a collection. I don't want to have to do pointer math. Because one of those two things is likely to blow your program up. I mean, it's not writing stuff in assembly, but that's that's more complex stuff. It's capable of more complex stuff, but that means you have to do more complex stuff. Where was I at? It's doing a thing. Okay. All right, we're applying the position. And we're applying the offset. So in the visual, I can set the offset. We look here from the center of the sprite. We're 32 by 32, so that means the 0, 0 is at the 16. So it's kind of here. So if I want it to be centered on the feet, the offset needs to be down about that far, which is 12 down. So plus 12. Godot space is positive down and right. Real quickly, gonna step away. We're a little after our normal hour break, so I will be right back. we're back. Okay, so we need to offset it. Okay, so we need to go 12 lower, which means we need to raise the sprite by 12, so that's minus 12. So this is offset y. This will totally work the first try. And I will definitely call out one thing to be aware of is, while I discourage people from diving in with C++ when they don't have an idea, like when they're just trying to learn, that to code or to start with game dev, like just trying it out, that doesn't mean if you want to learn C++ or you think, hey, I want to learn Unreal Engine, just do that. Go for it. But if you just want to like try things out, start simple, then try things out, start simple. Okay, well, I totally broke visuals. Okay, we are applying offset before we have a sprite. Okay, we can't just update position when we apply the offs, well, when we do that. All right, let's if there's a sprite. Oh, that's not available. So it's kind of shorthand for this anyway. Sprinte. No, sprite. But yeah, just doing things is pretty much how you want to learn. There are tutorials out there. Use them. There are guidebooks and whatnot available. Godot has very robust tutorials and documentation on its own website. Make use of that stuff. Don't assume that you're going to go in there knowing everything. Heading into this project, I never touched Godot. Didn't mean to run this on the C# side. C# side is a little... All right, well, we're not getting any movement in the visuals. We're calling the base on position and yeah. Oh. Womp womp. Actually update the position, that would help the visuals move. Come here, you. This was getting up and walking around. Sky was requesting permission to get some food. I still want to change the file loading. Right now, it's kind of a battle royale amongst all of the files to finish. I do want to change it so it is a series of passes. That until we're out of files to load, it will iterate over the unloaded files and say, okay, if this one completed, then move on to the next, move on to the next. If it doesn't, if it can't complete, we move on. But if it does complete, remove it from the list and iterate again and again. That way, every pass should be completing a few of them, as opposed to the sort of... It's kind of a race, you know? There we go. Just make sure that yarn ball hits and bounces. Okay. Save. We're going to do an interim commit here. We are set up here. Okay, offset for the sprite, still not right there. See, in theory, we should always update the position and apply the offset. But there could be wiggle to that. So we'll leave that for the time being. I decided that it was lap time was over, so got a bit of a kickoff there. So the first entity to come into existence is the player. So the entity visual offset y of -12. Those are public properties, so they should be getting loaded in. Something's not quite right here. Copy constructor should, again, first entity to be created should be the player. Shouldn't end the code in the middle like that. It's not really healthy. Visual sprite. Yeah, that's a yarn ball. I mean, okay. Now, we should be able to see it more cleanly in Godot. The the offset is not being applied properly because the initial entity set doesn't have the right update. Okay. Couple of things we have to do. So first is, so we set position here in the, when we create the sprite, we need to apply the offset as well. But additionally, when we're applying the offset, we need to multiply by the visual scale. Okay, so we're not quite standing on 0, 0 there, so that's not quite right. Tried to click the start button in the scene. Hey there, Lunar. Let's see, did I add the fishing minigame that uses catbot fish cell stage style? Catbot fish cell stage style. That's pretty close, though. And it's about the right size, too. Oh, well, that's the wrong mask entirely. Here to there. It's 14. The little blue things are nanoblobs. They will be in the game, just not initially. Those come later. But they're very cute, so I'm using them for now. There we go. Player is right on 0. Excellent. Now we've still got to get the shadow in there. All right. The little bouncing blobs are enemies. Little thing in the center, the little robot, is the player. And then the little pink balls are yarn balls. Those are our current testing bullet. Yarn ball will be a thing. It's just, it's not what it will be. Okay. All right, let's look at the blob. So if we look at its base form in a similar fashion, its center is currently right about here. So it needs to go up about 7. So the blob visuals would be -7. Some sort of death effect on the yarn ball, either visually or functionally, I definitely think is in order, Lunar. At least some visual effect that the yarn ball like unravels and falls apart instead of just vanishing would be kind of neat. Just player visuals. Let's get our enemy visuals. 7. So I think similar, a radius of 2. Radius of 2 and a height of 16. Let's try that. Hey there, no name. We're using off-brand Excel because I don't want to deal with an Office subscription. This is how we do our data files. We have a comma delimited data file that gets parsed into JSON, which gets loaded into data objects. Oh yeah, functionally I like JSON, but for a while we were using it, but it just required so much like hunt and find. It's easier for me to have a whole bunch of objects in one file and be able to like visually parse them and sort them than it was to have all the JSON. There's just so many things. All right, enemy data file. What game am I making? Well, let's see if it's still functional. I've just messed with some of the data files. It might explode. We're making a Bullet Heaven style game. Yeah. That looks about right. We could tighten the circle or the hitbox for the blobs in a little bit. But I think that'll do. For reference, we're working on collision right now. This is the core system of the game, though. Yes, you survive the swarm. Basic mechanic. We have a series of weapons and then a series of modifiers that we can use on them. So I can make the yarn balls move in an S-curve, fire in a burst of 3, and split into 3. So now they move out in an S-curve in little clusters of 3. They fire about once a second right now. We can then say they'll explode on impact. So this takes the second weapon, and when the yarn balls have hit twice, since they bounce by default, they can blow up, like we saw over there on the side. Yep, you can really get out of control with this. That's the idea, Vartech. That's the idea is when you level up, the general option will be you might get presented with a new weapon, but you're more frequently going to get presented with modifiers. The pale blue circles that are heavily overlapping right now is Godot showing me where the hitboxes are. We can then get really out of control. Let's save our eyes just a little bit here. So performance is a little tighter now with the way that we're doing visuals and similar. But we have more than 800 things, noticeably more than 800 things in existence at all times right now. And we're getting about 8 frames a second. Yes, this is Godot 4.4, no name. And again, we can make it worse. We can do one stage worse. There's a lot of optimization that we're doing to make lots of things on screen work. Yes. There's a great deal of per bullet going on. There's also a great deal of collision detection. Every one of these gets processed once every physics frame. We could tune that down, but at the moment it's every physics frame. Hey there, Colin. So this is fires in a burst of 3, splits into 3. So each of those 3 splits into 3, then those split into 3, then those split into 3, then those split into 3. So every second, we're firing 3 to the 5th projectiles. And then, after 3 seconds, every second, they will emit an explosion. So we're going to see our number of entities that is slightly blocked. Let's see. We're over 2,000 now. Let's say 2,500 minimum. It's probably more like 3,000 to 4,000. But we're still in single digit, like greater than 1 frames per second. If I then, if I go to my menu and stop, the frames per second will climb back up somewhat. There are a lot of things on the screen right now, even if they're not moving, so there is a cost to that. But if I tune it way back down, it'll take a moment because these have to die off. They live like 10 or 12 seconds before they time out. The bounce calculation is still off. I did something that broke it at some point, and I'll have to revisit it. But now we're back up with what is on screen right now, which is not an unreasonable amount of things. Let's make it more so. Like, this is a lot of things active right now. This is not a like end game state, but this is a powerful weapon in play at the moment. It's got reasonable coverage, and it can hit a lot of things. So we're still at, let's say 200 frames a second with more than 300 entities in existence. Very nice. Very nice. So one of the next things that we're going to be working on is getting the shadows in place. This will affect performance still more. What's the matter? Come here. Come here. Ember's being all hyperactive. Yeah. He's a very talkative cat. What? While I'm thinking on this, so one of the things is the default motion on the projectiles is straight line initial target at an enemy. So it picks a random enemy and it draws a direction to them, and then it just sticks with that direction. It doesn't home on them, it just says this is the direction to that enemy at the moment. Hey Hendry, welcome. But that is an additive vector that it is doing. So it's that movement says move a distance. The zigzag motion does not do that. It rotates the direction that it's going. It doesn't push on it further. The spiral motion is motion. It adds to it. So putting the spiral in there is going to make it move faster. It will cover more ground. I'm not sure I understand the question, Henry. Voice has been a little bit raspy past couple days. I don't know why. Is a mystery. All right, let's get an interim commit in here. Oh, okay, yeah. My sleep has been heavily disrupted the past week. So, I haven't really been able to do a regular stream. But, you know, knock on wood and all that, should be able to stream this week. We'll see. We can get similar to today. It'll be great. Hey, Harry. And welcome. Those, push that. Okay. So the next thing we want to do is the shadow effect. So one of the things that we need to decide is if the visual intrinsically covers this, or is it something that I have to define in the entity? What sort of shadow does it have? Because if it's part of... What do you mean, Vartek? The boundary? You mean like edge of screen or what? Hello, Sherbet. Hey, buddy. It's the number of things that you're going to be able to add to a weapon in what they do is going to be a great deal of like tuning of content. Because I want every power-up that you can add to a weapon to be... Every power-up should be compelling. There should never be that power-up that somebody would look at and say, why would you ever take this? Like, we want everything to have a, this is valuable because. It's okay for you to look at it and say, but I don't want it because. But there should always be that factor of, if I were doing a different build, I would want that. Or, you know, if I hadn't made this choice earlier, I would totally take this. Right. Right, Lunar. Even if it's a niche thing, even if it's a power-up that, you know, is useful if you start going down that road, that still means it looks attractive. The ones I have right now are, one, way too powerful. The shot multipliers, like the burst of 3 or the split into 3, are fantastically powerful things. They, like, right now, it triples your rate of fire to do a split into 3 or a burst. Way more things on screen at once. It's something like that will exist, but there's going to be a greater cost to them. It's not so much a trade-off, but there is a... They don't operate immediately, so... On a bit of a tangent again, but let's go. So let's say I had burst of 3. That's already pretty good. So 1, 2, 3, 1, 2, 3. And I could have the little wave pattern, which technically gives you a little more coverage. Great. So, this is way too many enemies, by the way. This is... they wouldn't move this fast, and you wouldn't have this many right at the beginning, but for testing purposes, it gives us a lot of targets. So, what if I have 1, 2, 3, and a... the S-curve again? That's still, like, that's better than default. But if I wanted to have a split into 3, most likely it would operate like this. So 1, 2, 3, then split into 3. So it takes it a little bit of time before it splits again. It's still good. It's still very good. But it does not immediately flood the screen. Swap out the wrong one. Yeah, I did. Let's get the example as we want it there. But yeah, it's... What we're likely to see is a combination of a great deal of breadth. So lots and lots and lots of different power-ups created, combined with like layers of rarity. So there's 100 power-ups, and each of one of them might have multiple rarities to them, so that you look at it and say, well, I wasn't thinking of using this kind of power-up, but I got the ultra rare version of it this run. Oh, okay, yeah. Distance and lifespan of the projectile is another thing that is a balance factor. So, for example, let's reset it just so that we clear the screen a little bit. Let's get a good number of them out there again. If I had more delays, I could really show this, but and we'll have them bounce again and pierce again. So they can hit a whole bunch of things. They live for like 10 seconds. Some of them, like, there are going to be projectiles that are faster and shorter lived. You know, they go out and they might hit something real quick. There might be some that are very slow and live a long time, or any combination thereof. Yeah, one of the performance things that I don't have in is actually if it's too far off the screen, just make it go away. Because if a bullet gets all the way off screen because it's moving super fast, eventually you don't care about it. Like, could it come back? Yes, technically. If we do like spiral outward motion. So the way that these move, it makes it possible that they will leave the screen, but then they're moving fast enough that they could make it back. So we want a little bit of wiggle, but if they get far enough away, I'm just going to despawn them. They don't need to come back. But this is an indicator of how powerful these are. 3 of them in a row, and you have ridiculous coverage. You get more saturated coverage if you do it that way. It can get very pretty. Every now and then it's fun to just do this. This is another one that's very powerful. Right now we have the little explosion that was happening at my feet. That is... how to put it? So how the explosion works is it's not that it blows up on impact. It's that it takes the next weapon, so the next weapon after the yarn ball is the explosion. This effect, and we've got a little bit of a visual indicator on it. The pink is where the flow is coming from, the blue is where it's going. So this explosion has blue below it, so it's going to take that next weapon, and it's going to commandeer that. So this weapon stops firing by itself and now fires after that projectile lands its last hit. So if this was another bullet, then I would have a whole extra row of special effects that would initiate when this bullet hits. So if this bullet has already split into 3, I could have this split into 3. Again, voice is very raspy today. You know, I haven't tried this. I don't know what burst would actually do here. That requires more looking. So with this, what's happening here is when this one spawns, it says make 3 of them. Normally the explosion doesn't move at all. But by putting this spiral out, in its first frame, it splits into 3, and then moves each of those 3 in an outward spiral, adjusted by the fan of the split. So you're seeing kind of little overlapping ones. But yeah. If and we've got a radius of 2 is so far pretty good. So then we're going to go into the bullet. Visual should be a -2. Well, thanks for joining us, Vartech. So this should be offset Y -2. Then go into the bullet entities as well. And it's collider instead of circle 4. It is capsule 4. Run it in Godot because it loads faster. I would still say that that's pretty good. The collision box for the yarn ball is smaller in this fashion, but it gives us a definite position for it. Some projectiles in things like explosions would still have an absolute circle. and some things won't have a drop shadow. But I think that's something that we can attach to the visual, is whether it has a shadow and which shadow to use. We'll have to see how that goes. All right. Nice thing is I can reuse a lot of these colliders by just specifying this is how big it is. If it'll fit another enemy, I can just pop it on there and say that's good enough. Because we really only need a sprite for this. It doesn't need to be an animated sprite. The sprite doesn't need anything but the texture. That still doesn't mean we can reuse it. Anything that has a shadow. Yeah, okay. So a shadow is always, we're going to make a declaration here. A shadow is always going to be a sprite texture that will be loaded and kept at the at the 0 position. So whenever we assign a node, we're going to immediately create that. And whenever we remove the entity, we remove that shadow visual. So right here, as soon as we have the node, we can attach the shadow to it based on the visual that we're using. Oof. Second, let me check a couple of things here. Okay, we're actually going to wrap up here, folks. Voice is still weirdly raspy, and I hit the wrong thing. There we go. Voice is still kind of raspy and getting a little bit more tired. Don't want to push it. Again, may still work on this between this and the next stream. Hopefully that stream is tomorrow. Next thing is going to be getting those shadows in there. What we're going to do is we're going to give it a texture identifier that's going to load that texture in and make it available to the visual object. And it's going to glue a sprite of that texture with a change to the z-axis, the z layer of the object, so that that all of the visuals are always above, or should always be above the drop shadows. with the goal being that the drop shadow that we create for an entity matches the general dimensions of the shadow, so that if you can see the shadow, where do I code, Drew? I code on like the same PC that I do like my gaming on, that kind of thing. Yeah. Okay. But what we accomplished today, we added the offset logic in similar to the visuals, and we started down the road. Unclear, Drew. So, I stream on YouTube and Twitch. So my coding streams are on both those platforms. You're on the tall format on YouTube. There is a wide format. My IDE is Microsoft Visual Studio. Thanks for joining us, Hendry. Thanks for joining us. Godot is from their website. So I expect it's one of those things. My source control is GitHub. I have private repos on GitHub. But yeah, I do hope everybody had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, drop a comment, that sort of thing. It helps the channel grow. If you'd like to consider financially supporting the channel, there are links to various platforms in the link tree in my bio and in video descriptions. But yeah, with all that said, I hope the rest of your day is good, and I'll see you next time.